Welcome, ladies and gentlemen. So what I like to do is show you how to solve the systems of inequalities. And what you can see here is I have a system of inequalities, and they're both in both my inequalities are in standard form. So you can see that standard form ax plus by equals c, which is standard form for equation. But inequalities, it's going to be the same thing. So when we're looking into graphing a system, what we're going to want to do is graph each inequality separately. And when graphing an inequality, I like to think of just graphing the equation rather than the inequality, because we basically use the inequality symbol to show us, the solution points, or points that are going to be a part of our solution or not. So as far as graphing the boundary line, we can just think of that as like graphing an equation. However, we do got to be careful not always shading them, because sometimes our boundary line is going to be solid, and sometimes it's going to be dashed, which is going to be based on the inequality symbol, which we'll go over. Now, when we have an equation in standard form, there's two different types that we look into graphing. One way is using our intercept method, which I'll show over here, and the other way is using slope-intercept form. And sometimes it really just kind of depends on what you're most familiar with, what you like, and if you're going to be dealing with fractions. And the best way I like to say is not to use intercept form is when your constant is not divisible by your both coefficients. But in this case, negative 16 is divisible by 4 and negative 4, so I'm going to use intercept method. So to do that, all I'm basically going to do is going to determine my x and y intercept. So the x-intercept is the value of x when y equals 0. So to solve for that value, I'm simply just going to put 0 in for y, and then solve. 4x equals negative 16, because that goes to 0. Divide by 4, x equals negative 1. So since x equals negative 1, y equals 0, I can write this as the coordinate point, negative 1 comma 0. Excuse me. Now let's go ahead and find or determine the y-intercept. And that is when x equals 0. So now I put a 0 in for x. That's 4. I don't know why I went through that. OK, so now that multiplies to 0, divide by negative 4, divide by negative 4, y equals positive 4. So now, since y equals positive 4 and x equals 0, I can write this as the coordinate point 0, comma 4. So now, to graph my equation, I'm simply going to have my x-intercept as negative 4, 0, 1, 2, 3, 4, and 0, comma positive 4, 1, 2, 3, 4. And the important thing, again, is to go back to the equation and look at your inequality symbol. Since this inequality symbol is greater than or equal to, that's going to tell me I'm going to be graphing a solid line. All right. So now let's go and get into graphing the second inequality, which I rewrote as an equation. And I could graph this using my intercept method. But in this case, I'm going to determine by graphing the slope-intercept method. So to do that, I'm going to want to rewrite my standard form into slope-intercept form. And we do that by isolating our variable y. So to isolate it, I just need to undo all everything that's being applied to my variable. So I'm going to undo addition first. So I have 2y equals positive x minus 4. Now I need to divide by 2. And therefore I have y equals x divided by 2 can be rewritten as 1/2 times x. And negative 4 divided by 2 is negative 2. Now, when we have it in slope-intercept form, we need to understand what the slope is, as well as what the y-intercept is. So when graphing in slope-intercept form, the first thing we're going to do is plot our y-intercept, which is at negative 2, and then use our slope as a rise over a run, or our change in our x, or change in our y values over the change in the y values to find the next point. So this would be up. Since 1 is positive, I'll go up 1, and then since 2 is positive, I'll go over 2. And it looks like these will eventually intersect, but it's going to be somewhere all the way over here. So when graphing the inequalities, we're not going to be so concerned about the exact intersection point, but mainly going to be all the points that are going to be a part of their solution. And I forgot, you got to be careful. Ladies and gentlemen, this is the big mistake that a lot of students will make, and I made it because I was talking, I wasn't thinking. Notice on this inequality, this is greater than, correct? So since it's greater than, I'm going over to 2. Up 1 over 2. Since it's greater than, what that tells me is now I need to, since it's greater than, what that's going to tell me is I need to create a dashed line, not a solid line. Okay? So the next thing is we need to determine our shading. And that's where we're going to go back to our inequality symbols to determine where we're going to shade. So we already determined if the boundary line is a part of our solution or not a part of our solution, depending if it was solid or dashed. Now we need to determine what about all the points above or below the line. So basically the best test point to use is 0, 0. And as long as your two lines do not go through those points. So to test 0, 0, all I'm simply going to do is enter 0 in for x and 0 in for y, and determine if it makes my inequality true or false. So I'm going to test this line first. So I have 0 minus 0, which is 0, is less than or equal to 16. So this says 0 is greater or equal to 16. So I'm testing the test point 0, 0. That is true. So that means for this line, since my test point is true, I'm going to shade below. Now let's test this point. So again, I'm going to put 0, 0 in for my inequality, or in for my coordinates x and y. And again, I get 0 is greater than negative 4. So for this boundary line, again, my test point is true. So I'm going to shade, again, above the line. So now I just shade between these two lines. So there you go, ladies and gentlemen. That is how you solve a linear inequality. Thanks.